And we're back. That was so fast. So hopefully you tried to do the practice problems yourself before watching this video. It's just a great way for you to see for yourself if you understand what's going on. And then again, if you still don't know what's going on, you need more extra support, please come to office hours. Please. I'm just chilling there. Okay? So let's get started and do some practice problems. And here we go. All right. So the first one, let's see how this looks like on the regions. So these are all regions questions. In the diagram below, circle O with diameter BC and radius OA. Chord DC is parallel to chord VA. Always mark up your diagram. I didn't even finish reading yet. Mark up your diagram. So diameter, blah, 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 radius, okay, we'll get there, chord, okay. But when something is parallel, there's something to mark up. So it says DC is parallel to BA, DC is here, BA is here. Now hold on. We just learned that when chords are parallel, the arcs that they intersect are congruent. So that means DB is congruent to CA, right? It's kind of like cutting out like a rectangular-ish type shape, okay? All right, then it also says angle BCD is 30. So BCD, that is 30 degrees. Whoop. And we want angle AOB, AOB. So somehow we got to get that angle. All right, cool. Now, what a lot of you have been telling me, for those who came to office hours and for those who've been chatting with me, is you don't know where to go. And what I've been telling a lot of you is you just got to follow your nose. You need to produce a number in the end that tells you the measure of AOB, right? And the only number that they give you is 30 degrees, right? So you're going to have to do something with that number, okay? So angle DCB. If you check this out, I'm going to highlight it and then I'm going to erase it so it doesn't become a messy picture. Whoop. That's an inscribed angle. So if angle DCB is inscribed, remember the angle is half the measure of the arc. So that means the arc is double the angle, right? They're opposites, okay? So if the angle is 30, the arc is 60, okay? But hold on, based on what we already wrote, isn't arc DB congruent to arc CA? So then this also must be 60. Whoop. Okay. And I'm just really following my nose. So we got that CBA outlines arc CA. Remember, the angle is half the arc, so that means angle B must be, 30. Now, we could have done this a lot quicker. You might be asking yourself, how could we have done that, Mr. D'Souza? Well, outline the parallel lines and the transversal. And that parallel lines, it creates a Z, and we know that the angles within the Z are congruent. Now, I'm realizing that actually we didn't need angle B. We can do this even faster. But do you see how like I was instinctively trying to find every single angle? That's totally fine. What I tell my students all the time is follow your nose, use the information that you know that's mathematically correct, and eventually you'll get your answer. So I'm sitting here and I'm like, okay, I got angle B, got angle C. I'm trying to get that purple angle, that angle AOB, but I'm not going to get it this way. So let's see if I can go a different route. Check out this. COA is a central angle, right? Hi, Riley. Hello. I'd pick him up, but he doesn't like getting picked up, so just pretend he's there. Hello. So yeah, angle COA is a central angle. So that means central angle, we know, are equal to the measure of the intercepted arc. So this is 60. And check this out. This angle, because we know this is a diameter, so it's a straight line, forms a linear pair. So 60 plus what is 180? 120. Great job. So the measure of angle AOB is 120 degrees. Boom, done. All right, next one. In the diagram below of circle O, chord CD is parallel to the diameter of AOB. The measure of arc CD is 130. Should be degrees. Interesting. So before you do anything, before I even read the question, mark up your diagram. So it says that CD is parallel to the diameter AOB. Diameter is going to be important. I'm going to underline that. And we want to figure out what the measure of arc CAB. So CAB. This is what we want. Oh, this is perfect. I'm outlining it perfectly. Whoa, even with the lag, that was beyond perfect, as it should be. All right, we know that arc CD is 130 degrees, okay? And then just to fill in more information before we even solve this, parallel chords intercept congruent arcs. So that means this arc, CA, is congruent to this arc, DB. Okay, again, you might ask yourself, Mr. D'Souza, I don't know where to go from here. Okay, follow your nose. They only give you one number. You have to do something with that number. And then the only other thing that they gave us is that AOB is a diameter. So check this out. Do you agree that because AB is a diameter, this whole yellow arc equals 180 degrees? Yeah, it should, because the diameter is half of a circle. If a circle is 360 degrees, half of a circle is 180 then. But didn't we also say that this piece over here, CD, is 130? So I want you to watch how I'm doing this. The whole thing is, the whole yellow piece is 180. And this purple piece is 130. So if I subtract this purple piece, I'm left with these two yellow pieces. Okay? So mathematically, what I'm doing is I'm doing 180 minus 130, which gives us 50 degrees. But remember, 50 degrees is both yellow pieces. But we know both yellow pieces that are left over are congruent. So we got to split 50 in half, right? So we can share 50 to both. So we know AC is going to be 25 degrees. And we know DB is also going to be 25 degrees. So that's really good because, check this out. I'm going to erase this. I don't care about this piece because I need C to A all the way to B. So I got CA. That was the hard part. Okay? But remember, AB is a diameter. So this black arc, so arc AB, this one, is 180 degrees. Okay? And to get arc CAB, we're going to add 180 plus 25. That's 205 degrees. So the measure of arc CAB is 205 degrees. That's it. Let's do the next one. In the diagram below, quadrilateral ABCD is inscribed in circle P. That means it's a cyclic quadrilateral. That also means that opposite angles are supplementary. Okay, so we want to know what is the measure of ADC. So angle ADC. So A to D to C. Now, they're kind of tricking you. Okay, why are they tricking you? What do you think they're doing? And I'm back. My cat is being too much every time I'm recording. Anyways, they're giving you actually a lot of extra information. There's several ways you could do this. I'm going to tell you both ways. First way you can do this is because you know that, actually, I'm not even going to make it complicated. I'm not going to make it complicated. You want this angle. This angle, so ADC, is opposite this angle. We know that angles that are opposite each other in cyclic quadrilaterals are supplementary. So 180, oops, I'm lagging. 180 minus 72 minus, woo, that was crazy. My mouse just went crazy. 180 minus 72. 72. What is wrong with my computer? It's probably because I'm uploading another video as we speak. 180 minus 72 is 108 degrees. So the measure of angle ADC is, what did I say? 108 degrees. 108 degrees. Okay. Let's do the last and final question together. Quadrilateral ABCD is inscribed in circle O as shown below. That means ABCD is a cyclic quadrilateral. All right. So if angle A is 80, angle B is 75, angle C equals YE plus 30, and angle D is X minus 10 degrees, which statement is true? Now, I know a lot of you are going to be like, what is this? You didn't show us this. We didn't do anything with the variables. Don't worry. We only know one thing, one property about cyclic quadrilaterals. Opposite angles add to 180 degrees. So I'm going to pick two opposite angles. Let's pick angle D, because that's what my name starts with, and angle B. The property that we know is that if we add those angles, it equals 180 degrees. So 75 plus, now angle D is written a little bit weirdly. It's just written as an expression. Who cares? Angle D is the same thing as X minus 10. So 75 plus this X minus 10, that should equal 180 degrees. Well, let's combine like terms. So we got 75 plus X minus 10. Okay, we don't need the parentheses. Again, I'm going to use my calculator, right? You could definitely do this in your head. I could do it in my head, but if you make a mistake, you shouldn't. Use a calculator. Use your phone. Also, side note, that's why we're also doing this unit too. Everything in this unit is adding, subtracting, multiplying, dividing. There's no like sine, cosine, or graphing or anything like that yet. Okay, so 75 plus negative 10 is 65. As I tell my students, don't be a hero, use a calculator. Okay, and we want to solve for x, so subtract 65 on both sides. Whoop. And we get x equals 180, whoops, 180 minus 65 is 115. Now we got x equals 115. Now you might be like, Mr. D'Souza, we got to find y. No, you don't. At least not in this problem. Check the answers. Be smart. Work smarter, not harder, right? All the answer choices, all the x values are different. So the one that I chose must be there, right? So x equals 115. The only one that's there is this one. That's it. We're done. It's choice 4. Now, if you did it the other way, you could have chose angle A an angle C. So you could have done 80 plus y plus 30 equals 180. And you could have solved 80 plus 30 was at 110. Subtract both sides, blah, 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 blah. You get 70 degrees. Or rather, you would have gotten y equals 70. All right, so before we end the video, between the mini lesson and this video, how many smiley faces were in the video? Okay, so you can't count this one that I drew in black in the middle of the screen. That doesn't count. Okay, put it in the comments below on Google Classroom, and I will give you some kind of extra credit or some kind of surprise or something like that. Anyways, I hope you all have a great rest of your day. Enjoy your weekend. Also, there's going to be some kind of castle learning thing that we want you to do because you're going to have a test probably next week Thursday or next week Tuesday. We'll let you know. But you need to be able to use castle learning, okay? Because we know you do it in your other classes. So we know. Anyways, see you later, everyone. Have a great day.